So as you can see, I've got the Amiga 1200 removed from the case. The RF shields have been removed. And we're going to dive into a couple of capacitors here. So I'm going to go ahead and leave this video card on, even though these caps are pretty close here to it. Just I don't want to take a chance on popping it off and back on and bending a pin down in there. I think I can work around it. I think there's sufficient lead length here, if I can find a pointer. There's sufficient lead poking out on the two sides here that I can get the pencil in there, and I think I can actually work with the gap there with the small tip. So I'm just going to work through and replace these four. These are all 22 microfarad, 33 volt. These are supposed to be non-polarized, even though they're polarized caps. I was correct in the previous video in the kit that I ordered that it has 5 of the 22 microfarad 35 volt caps here that replace these. See, a little disappointed there wasn't any non-polarized in here. I may actually go look at the bench. There appears to be a tantalum surface mount here as well. I'm not sure where it goes. It's labeled for red 10 microfarad 25 volt 2B only, and that may be for the 2B board revision, which means it doesn't apply to my board. I've actually got a larger tip on the pencil. I'm going to hot swap the tip here on the JVC. It'll come up to temp really quick. Get a little bit of solder here because I'm going to need it. Now I have seen a couple videos of people just taking a pair of pliers and twisting the cap and popping it off the board. That just seems crazily dangerous to me in the realm of lifting traces. I don't know how well this will show up, but that's a really fine tip on my JVC. I think that's actually the smallest tip I have. Because of the really excellent thermal capacity, the JVC, I do expect this, however, to melt that solder pretty quick. Hopefully. Let me add a bit of solder so I get a little more heat transfer. Let's see if I can actually get that to release with this tip. Don't like the way that felt at all. It does appear to be loose. Not coming off as easily as I would have liked. This tip may just not be up to the job. Get in here and touch a bit of fresh solder down in there. Yeah, this tip may not be up to doing the job here. I think I'm getting enough heat flow up under the cap. So let me hot swap this tip again for a larger tip. I guess it's possible these are glued down. I guess that is possible, that these were glued down. And that's why there's so much resistance to getting them off. Some components get glued down. There it came. Oh fuck, and I lifted a trace. Son of a bitch. Well, you saw me do it. Heat gun would be better here. Yeah, I definitely lifted that trace. That does not make me happy. Wasn't glued down, I just didn't get enough heat. I probably lifted that trace when I pried previously. Shit. Well, that's why I'm working here where I have more room. That really doesn't make me happy. I'm going to have to tack a piece of wire along there. Luckily the trace is obvious. I felt that lift and rock up off there just fine. Not having a lot of luck here. See if I can get the heat to flow. And it did. Side lifted up. This is certainly not the best way to be doing this. Yeah, I can see working in behind that keyboard connector is going to be difficult. There's one side lifted. And there's the other side, and I didn't lift a trace on that one. There was a little via there. But I think I can get a piece of wire down through. Although the solder mask has it filled, I may have to clean that out. That's really tragic. Shit, that really doesn't make me happy, excuse the French. Let me see if I can clear the solder mask out of that one hole. It's the tiniest bit I have here. Very tiny bit, which drops down into the hole just fine. So it's really just, can I release the solder mask that's caught down in the hole? Oh crud, I broke the tip off the drill bit. No surprise. As you can see, not having a lot of luck here. Be a little more careful. I think I've actually got the drill bit broke off down in there. There should be two vias. Off the end of the keyboard connector. Yeah, it's right there. Oh, that makes me unhappy. There it goes through. So I think I just punched the other side through. You can see the hole is open. The bit's small enough I shouldn't have. I'm looking at this trying to decide how to rework it, and there is a via. There should be two more if I can see them. They may be underneath the chip. Yeah, they're underneath the chip. Because ultimately I need to bridge here to here. And that'll fix the trace where it's broken right there. Not optimum. Find a little piece of wrap wire here. That's actually the insulation off a piece of wrap wire, not an actual piece of wrap wire. Doesn't make me very happy at all. I didn't write down the orientation of these. I should probably fix that first. Sorry, sitting here looking at this, trying to decide the best way to fix what I just did. That disappoints me. I guess a hot air gun would work better. I don't actually have one. I don't do a lot of surface mount. Debating whether to scrape the solder mask away and just tack a piece of wrap wire all the way across that. And that might be the safest, at least the cleanest fix. So I think I'll stop recording, give this a bit more thought, and I'll be back. So I didn't actually capture video of this, but I'll talk you through what I did. Was we cleared out the via hole for that trace I lifted. I ran a piece of wrap wire through the via hole, scraped off a little bit of the solder mask, and tacked a piece of wrap wire onto the trace on the back. Probably didn't need to do that. That piece of wrap wire then comes up. I scraped the solder mask off the trace that was broke on this side of the board. Actually, I want to add a little bit more solder there. Along here. Just a little bit, just to capture it. And that piece of wrap wire is continuous, and it follows along the trace up to the resistor here that it was attached to. And then the capacitor is going to sit down over the top of it. Hopefully I didn't lose one of the caps. So the new ones are physically slightly smaller than the older ones. That's no surprise. I pulled out two caps here. There's the other one. And there's a couple different ways to do this. It may be better to remove all the solder from the pads. And that way the cap would sit down in place, and then I could rely on heat from the gun to flow the solder up underneath. Or from the pencil. That might be the better approach to this. The other possibility is to get the cap in place. And I don't do a lot of surface mount, so I don't have a whole lot of practice with this. So I'm kind of, doing this on the fly here. Well, I'm not going to be able to grab him. I think solid enough. Yeah, that's what I expected, was the cap to go flying. Don't think I'm going to be able to grab him with some can I use that to just kind of hold him down in place? The angle would have to be higher. And these are the two bulk decoupling caps around the audio. So let's see if I can. Oh, I just don't have a good pair of pliers for this. Something with a serrated tip. It's small enough to get a grip and hopefully not slip too much. Of course, I'm gripping a rounded surface. I just want to hold that in place there and get that solder to flow. And then get the solder to flow on this side. Certainly not the prettiest job I've ever done, but I do have it in place. The other cap then rotates 90 degrees. And we'll see if I can use a similar process without accidentally touching the pencil down on the PCB. And you know what, I'm working with grounded tools here, however I don't have the grounding strap on my wrist. Kind of got ahead of myself here. I'm really kind of worried about how I'm going to get these two caps here replaced, especially that one up against the connector. I really don't want to have to unsolder that connector if I can avoid it. Kind of get you set down in there. And this one's going to sit funny because I've got that piece of wrap wire underneath it. But it is what it is. It is my Amiga, so it was mine to screw up, as you saw me do. I haven't lifted a trace in a long time. I definitely want to get the cap soldered in on both sides. And that is rocking, which I don't like. That's partly because that trace is lifted. It feels better. So really the struggle is going to be to get that guy out of there. And this big old tip, it's going to be really difficult to work down in there. Really don't want to lift the trace again. Trying to get him to just kind of, nope, there, it released. Okay, that side released. Get something smaller, and I want to get down in here, right there. Add a bit of fresh solder there. Kind of wait for it to flow. Don't want to wedge too hard. Feel it moving. They didn't just lift a trace. No, I didn't. As you just saw, he was rather tricky to get out of there. These traces back here are super fine. I wonder if this was using lead-free solder. That's possible too. Actually, I think I'm gonna try to solder wick some of that up off there. You go to a tip with a little higher thermal mass. Ooh. The tip I pulled out is still rather warm, the previous tip. Get a bit of solder wick here. Oh, this is a brand new roll. I'm guessing that's lead-free solder based on how kind of gray it is. See if I can wick some of that up off of there. Didn't get a whole lot of it. It's not really lifting. I'm going to bring the tip temperature up a bit. I'm going to add some fresh leaded solder and try to get that to clean up off there again. That's better. The angle to this one's a little trickier. Pulled some of it, but not all of it. That looks better. And I need to lift this guy up out of here. I can see, yeah, the working space there is pretty minimal as well. It's pretty dirty. You need to be really careful here and just see if I can get him to rock up a bit. That's going to be difficult to get down into. From this angle, it'll be a little easier. Good, I didn't lift a trace. I just left a bunch of ugly lead-free solder behind. We're going to add regular leaded solder too. I've actually brought the temperature of the pencil up 20 degrees as well to 370, which might be a little hot. Again, I'm trying to get lead-free solder to flow. See if I can clean this one off. It's not too bad. And clean this one off. Not really very good. Add some fresh leaded solder again. Get rid of some of the thermal mass off the wick. You can see the wick wetting well there. So it is drawing it up off. Didn't mean to leave it soldered on. So we got the pads pretty clean. I'm going to go look for some non-polarized caps before I actually put the polarized ones in. So I really don't have anything suitable for replacing those in my inventory, which is kind of a shame. Get the dead caps back out of the way. Where is the strip with the replacement caps? So I'm going to go ahead and put the polarized in, as much as I don't want to do that. Assuming I can find them. Here they're hiding. So pop out two more of these guys. And I think what I'm going to do here is put fresh solder on one side. Actually pick the cap up and attach it to the one side, and then just go ahead and flow the other. Though honestly, holding that in place there might be able to just use some solder on the tip of the soldering station. Bring the temperature back down. Clean up the tip. Get some fresh solder on it. Put this guy down in place and just see if I can get some solder to flow there and latch onto him, which it did do. And we'll essentially repeat that for the other guy. These are physically smaller, which will give me a little more working room in there as well. The idea is to kind of hold him down in place about there. Actually be able to grip him long enough to get some solder on one side of him. Leave enough pad showing on the other side that I can solder it. And this certainly is not the prettiest job I've ever done. The working space here as well is really tiny. I'm going to go ahead and retouch this side just because I can. Really happy with that. Well, it's certainly not perfect. But it really is enough, I think, to go down, pop the system back onto the audio system downstairs and give it a test. The negative sides are towards the square sides of the outline, which is correct orientation. So these through-hole electrolytics should be replaced, but I'm not going to do them in this pass until I've tested. And with these two guys, you can see that this guy right here has no thermal relief at all to that big ground or power plane. So that'll be a bit interesting. Actually the cap, no, actually the cap is these two leads, so there is a thermal relief to the cap. So I should be able to fairly easily replace that cap. This guy here looks like he won't be too bad, and there's one other electrolytic up here. And in this case that one actually is, but it's right on the edge of that pore there. So before I do those, I'm going to power up test and hope that I haven't damaged anything else. So I'll see you down at the computer in a minute. So as is typical here on the channel, you're going to experience first power up along with me. I've got the Amiga far enough back together that it'll boot from floppy. I've got Arkanoid, which was written from a ADF file. I've actually played it before with only audio in one channel. I've got just a cheap pair of Dell computer speakers. I wired up a cheesy little adapter here to a couple of RCA jacks. We've got video hooked up. And let's fire it up and see what happens. Hopefully... Well, I heard the floppy head step back. It's accessing floppy. So we're looking at the individual computer DVI output here on this monitor. I've got the other monitor set up as well over here. So left mouse exit, right mouse to toggle, PAL intensity. Let's just exit. And I think it's actually decompressing right now. The executable into memory. It was cracked, compacted, adapted for PAL Amigas by the Star Frontiers in 1987. So this was cracked a long time ago. So as I remember, there's no audio on this until we get to actually playing. I can already tell that stereo sound. Nice. So that came from the left speaker. I'm kind of trying to hold it up here near the microphone. Oh yeah, we have stereo audio. So the issue was that cap. Oh, you get to see me suck here at Arkanoid. I don't remember what C does. Capture. Laser. I didn't mean to do that. Definitely stereo. The ball noise is on the left speaker, and the laser firing noise was on the right. There's lasers again. Oh, man. Very pleased, as ugly as my fix was. And I am the first to admit it was a very clumsy fix. I lifted a trace. I didn't have the right tools, honestly. I should have used hot air, really, to do that rework. I don't know that I'm going to approach the other surface mount capacitors unless I have to. Multi-ball. The mouse isn't working really well here. I'm not on a smooth surface. It's a ball mouse. It's not been cleaned particularly well. But by golly, I have a game on an Amiga. It doesn't do me any good. Oh, laser. Oh, that wasn't laser. Would have helped there. But we have stereo sound. It sounds reasonable to me. Oh, I moved the mouse and I must have picked it up a bit. Anyhow, obviously the issue was most likely one of those two DC blocking caps was bad. I'm happy this was enough of a fix to get me back alive. I'm going to crank the volume all the way up and have a close-up listen to one of the speakers. And there's a little bit of audio noise there in the background, you know, power supply noise, that kind of stuff, but nothing drastic. Let's pull the floppy out and boot to Workbench. Oh yeah, I don't have the expansion card in the system. I have no idea what I'm doing. Can I just close this shell? And yeah, I don't have my the CPU and extra memory card in the system, so of course it can't map. Control C. I have no idea how to close the shell here. I am very much a noob to the Amiga. Well, we'll fire back up Arkanoid. Anyhow, thank you for coming along for the adventure. I may go in and follow the signal paths I planned for. Did a lot of work up front. It was ultimately just for a bad cap, but it is what it is. But I'm going to wrap the audio fix, I think, video up here, and we'll talk soon.